Welcome everybody. Tonight we're going to be working on module 6. It's the last module for this class. The primary focus here is to work on working with external files, right? And this is a really powerful feature in any programming language. Python, and I'm going to say typically, is very elegant at doing this and very easy. But as I kind of prefaced before I came into the video, I was having some tech issues getting my samples to work earlier. And so I'm not sure where it's going to end up. So we'll see where we go as we press forward. All right. First thing I want to do is take us over to W3 Schools and let's look at their content here on reading files. All right. So in the very most fundamental of forms, the first thing that you're going to see is that the command for opening a file is very simple. The code that you see here does expect that the text file that we're contending with is in the same folder as the program file that's trying to access it. If you're wondering, can you, excuse me, losing my voice here. All right, so when we're working with a file and it's in the same folder, it's a piece of cake, but you can also, if you use certain tools or certain syntax, access files that are in folders in different places, provided you understand your operating system and how it addresses files, right? So typically when we're going to write programs, at least on this level, right, and this is an introductory level, it's either in the same folder or one folder down from where we are. So let's say I'm in the module 6 folder, I'll create a folder inside of it, give that folder a name, place my text file in that folder, and then access it through a folder and then file name convention. The one thing I do want to kind of preface you guys with here, and I want to do this not because you guys don't know how to manage your files, although that might be the case with some of you, but also because when you're managing files in Windows or the Mac OS, and both of these operating systems are guilty of this, they have dumbed down the operating system file naming on purpose. Okay, so you can read a lot into it as to why they would do that. But the general feeling, I think, is they figure people don't need to know this stuff, or who really cares, right? And the reality is, maybe regular consumer computer users really don't need to know this stuff. Okay, so we'll put that out there. And who is that? That's most of the public, right? But all of us are aspiring to be IT professionals, and I find that an unacceptable way to operate, right? And part of this comes from, I'll say maybe a little bit from being a little old school in terms of, back in my day, we had to really know the names of our stuff. Now, you guys see that I just created a new folder here, right? And the folder name is the folder name, right? But if I go into that folder and I right click and I create a new file, and I'm just going to create a plain old text document here, and I'm just going to call it whatever, just to kind of make a point. But you'll notice my file extension is visible. That is not the default for Windows or the Mac OS. In fact, if you go to the menu, and this is Windows 11, mind you, so I'm going to the options menu in Windows 11. If you are on Windows 10 and have the ribbon bar or the menu, there should be an options menu there that will allow you to get to this folder options menu, right? And on the second tab entitled View, there's this little switch box right here. And I think, my memory is telling me now that maybe we did this on the very first night, and I don't know if you guys recall it or not, but here's where it becomes really pertinent to us. The default for Windows is to have that box checked. And then what happens is that file extension disappears in the folder view. It's still a text document. It recognizes it as a text document. But if I want to rename this, notice it doesn't give me the .txt. So what do people do? They do this. They'll add to the end of it. Well, it says name it .txt. So you do that. But then in reality, what's happened is now you have a double file extension on the file. And if you're looking for whatever .text, whatever .text is not the same as whatever .text. You guys catch my drift. So my opinion here, and this is not a coercion, but an opinion, is that whether you're in the Mac OS and you're using Finder as your file manager, which is the default for Mac OS, or if you're in Windows using File Explorer, that you go in and you tweak the setting to always show your file extensions no matter what folder you're in. And I think as an IT professional, you owe it to yourself to be in that operating mode. Right. And right now I'm going to change it back because there's a difference between these. Now, this can also cause problems. Like if you guys are going into, let's say, the web program or really any coding discipline, and you're looking for a file, when you write code, the files that you attach to must precisely match what's in your code. One uppercase letter, one lowercase letter, or another real common mistake, by the way, is when you're naming something and you accidentally add a space to the end of the file name. That's a real common one too. You know why that one's real common? Because as you type, think about how humans type on a keyboard. Type a word, space, type a word, space, type a word, period, type a word, space, type a word, comma, type a word, space. You know what I mean? And it's really common, especially if you're typing fast, that you hit the space bar, you don't even think about it twice. Right. Well, that wasn't the problem I was having earlier, and we're yet to see if I'm going to create that issue. But I want you to just kind of take a look at this. Now, this file that they're referring to is somewhere on their server. We're not seeing it, right? But we can tell what the contents of that file are, because we are using the open command, which is standard for reading files. We're calling the name of the file. And then, of course, you can add optionally a switch to indicate, are you opening in read mode, in write mode, or are you creating the file, which is an X, right? So there's R for read, W for write, and X for create, right? So those are the three things. Now, if you guys are familiar with permissions in Linux or Unix, right? So this might sound a little familiar to anybody who's done that kind of study, where you have read, write, execute as permission sets, and that's kind of where that comes from. Now, if I open a file in read-only mode, I can look at the contents and cannot change them. If I switch that to a W, I can not only open it and read it, but I can change the contents and write them back. If I use the X switch, all it does is create the file. It's still on me to write something to it, right? And that's a separate procedure. So very, very simplistic. Now, interestingly, you can also omit the switch, and then it assumes that you're going to figure that out in the aftermath. Now, this is kind of an interesting thought. So I can take the file, whatever it is, read it into memory, store it in a variable, because that's what's happening here. And then I can do the read command to read it in the aftermath. My preference is always to use the switch, but it is possible to do it without. So I'm just kind of like placing it out there. All right. So that's an example of opening a file and reading it. And that's really kind of our first example. Let's take a look at this other example. And what the heck is this doing? What is 33? Yeah, well, if you start counting characters here, I think it gets up to character 33 and then stops is what's going on, if you're wondering. Now, related to working with files, there's a bunch of what we call file methods. So like when you're opening a file, there's these extra functions attached to them. And here's kind of a list of, most of the common ones. As you get kind of like working with files, you'll kind of explore all these different things. I have some great little examples I can show you that I do with my classes over at Gateway. not that these examples aren't good ones either, but you know, when I'm not getting them to work, they're not really, it's not really very encouraging, basically. Um, read is a really common one, so that's just reading in the contents. Write is a real common one. Another one is after you've opened a file into memory, you can start reading through it line by line. So if the file contains a bunch of text, next line a bunch of text, whatever that text happens to be, you can keep reading it in systematically. For those of you that are going into either like the data program or something like that, a real common file format to read in is what we call CSV files, right? Or other, text-based files, which are really collections of data. And you can not only read those in, but you can look for the separators, break them into columns or tables, and then process that data in ways that is really, really powerful. And Python does this very elegantly and very simplistically, which is one of the reasons why it's used so much for data science, because it just is so good at doing it without writing complicated code. And I think that's really kind of cool, right? It was kind of built to do data processing, um, very much so. All right, so that's all we want to look at right there for now. Um, we're going to try these steps here, and you can tell I'm a little pensive about them because I wasn't getting them to work before, but hey, maybe they'll work now. Maybe the magic, is okay. I'm going to go ahead and close my Anaconda Navigator here. I may switch to a different IDE. I'm just putting it out there. Maybe it won't be necessary. We'll find out. I'm being confident, and I just closed the lid on my other laptop, by the way, right? Because it's going to work. Got to have a positive mindset sometimes. All right, Visual Studio Code is up and running. I have my cheat sheets up on the other screen here. And let's follow the steps. Okay, so it says in your project folder, create a directory called lab1 files. So let's do that. I'm going to come over to Visual Studio to do the file management. And I've preemptively created a folder for the Module 6 labs. And you can see that. If you have not done that already, you can do it either from within the product here, or you could do it externally in the file manager. That's up to you how you choose to proceed. I tend to do a mix. I usually, real frankly, like to use the system file manager. I find it a little less clunky than a lot of like these tools here. But you can see that I do have the folder here, right? And what they want us to do is create another folder inside of it. So for those of you working inside of Visual Studio, make sure you just highlight the folder that you want to create it in, and then just click the new folder button, and then call it whatever you wish. It doesn't really have to match what's in the lab assignment. In the lab assignment, they said lab 1 files, capital L, capital F, no spaces, right? So let's follow that approach. Lab 1 files. Right. And I'm not sure what happened there. Well, it's there. Oh, I think it's because it's blank that it's listing like this. That's kind of an odd format to me, that it's not expanding. Is yours doing the same thing, folks? Okay, so I'm getting like a mix of, yeah, I'm not really digging that, real frankly. All right, inside here, I then want to create a new file, and we're going to call it hello world. Notice the dash, it's not a space, .txt. And I'm opening the file, and then I'm going to type in some stuff. It can say whatever you want. Doesn't matter what's in there, but after you've put the stuff in there, save it. I'm a little suspicious here that it didn't go where I wanted it to, but it did, right? And I'm not sure why it's like formatted like this. I'm going to call it a quirk of the product. I will tell you, it makes me uncomfortable though, because with all the issues that I've been having with this product here today. All right. So now that we've created it, now we got to do the coding. So let's go back and now in the module 6 labs folder, I'm going to create another new file. And this one is, well, you can name it whatever you want, but my naming convention thus far has been to name the module. So this is module 6, lab 1.py. That's been my pattern. All right. All right. So first thing that we're going to do is we're going to create a variable. Now, I'll be real frank, like what you name something for the variable to hold a file is highly subjective, right? Now, when I usually teach my students at the other school, what I usually tell them is a lot of people call this an in file because it's an inbound file. And often we abbreviate that, by the way, as this, like INF. And I know when I see that, it's an inbound file, right? However, following Patrick's example here, we're just going to call it file. And then we're going to issue the open command. And then here we're going to provide the name of the file and the path, right? So this file that I'm creating right now sits above this folder. So I need to include the path, which is lab1 files. Now, even though Windows does backslashes for the directories and folders, they're the only operating system that does. Everybody else does it with a forward slash. We put in a forward slash, and then we say the exact name of the file, upper lowercase, with the file extension. Now, ideally, you would also issue the read switch on this, right? Because we're not going to change it. We just want to see it. But once again, that can be optional. And if you hover over the command, right, you'll notice. And then they give you a whole bunch of, stuff, other stuff that you can do. But the first two items on this list are the ones that are pertinent to us. The file path, the file itself, and then the mode that we're using to open with. All right. Then we can hypothetically take a look. And this is kind of interesting. So we can do this a number of different ways, and provided it works for me, right? Since the file is now stored in this variable, now I can read the contents of the file and output them through the print command. And, crossing fingers here, we'll see if it works. And it's not working for me. Now, it might be working for you.
You misspelled world in the line 2.
Ah, all right. Nothing like a student pointing out your flaws here, right? All right, let's run it again. And you know what? This is what I've been getting all afternoon, trying to work with this and trying to troubleshoot it. Now, what I'm going to do just for the sake of it is I am going to launch my Spider IDE here. And I'm going to make sure of a couple of things. The first thing is that text file is not open anywhere else.
I had the same error too when I ran it.
Oh, you did? Okay. And did anybody else?
I have the same error.
Okay, so a lot of people are getting the same error. So maybe our Python is not fully installed. All right. So I'm thinking that maybe we're missing an extension. And then Tom, you're working in Replit. All right, so let me try this here because you can see I was experimenting with this product too. This, folks, is the Spider IDE, and I'm going to just very quickly kind of recreate the same thing here. I'm going to go to the same folder. I'm not going to open that lab. I'm going to create a new one. And so I'm not going to do an open. Let's just create a new one. Let's do a save as. And so if it works here, I'm going to stick with this product. And if it doesn't work for you guys, I think we're going to do a sideline and try to figure out why it's not working. But let's try, let's just get it to work first and then kind of go from there. All right. So I'm just going to call it lab1.py just to make it simple. We'll do file equals open. Do the same syntax here. Lab1 files / hello world.txt. We'll do the R switch for read only. And then we'll just do a very simple print command, print file dot read, like so. Doing a save, and now we're going to hit the run button, and there you see it works just fine. So this is kind of, I'm not sure what's happening over in Visual Studio Code, but I think it's really pertinent that we pause at least for a moment and see if we can kind of collectively figure it out. So we have, I don't know, 20 people here in the room tonight. If somebody's using a different IDE and it's working for you, fantastic, good for you. For those that it's not working, I think it's worth taking a look at this. Let's pause the video and see if we can troubleshoot it together. And there's kind of a value in that too, by the way. I think we maybe figured it out, and I'm saying that kind of pensively, but I think we figured it out. So we went basically to this website that somebody found here in class, and Anandi, I'll give you the tip of the hat here for finding that. So I don't know if you guys watching the video can make out that URL, but you can always try to zoom in or whatever. But there it is. And basically we're looking at this instruction. So inside of Visual Studio Code, went down here, went to the settings, which brought up this panel. I did a search in the settings for Python space terminal. In the list that appeared, I found this particular setting, and I did click it once, and then I'm like, okay, let's try it. And then I restarted the product and it wasn't working. And then I realized, oh, this is just a file. And the way that, by the way, that Visual Studio Code keeps its settings, I think, is in a JSON file, which is JavaScript object notation. But you got to click that, and then you got to come up here and actually click save, because since that's a file, it's not going to save it. I didn't even restart the product. And then I came into the lab, hit the run button, and now it's working just fine. All right, so I'm going to pause the video here for a second to see how you guys are doing. Hopefully that worked out for everybody, but just to kind of really quickly reiterate those steps, we went to settings. We came up here, we just basically did some searching for the command that we're looking for. And I suppose if you know that it's execute in file directory, right, you can just search that phrase, probably be more efficient. Click the checkbox, come up here and hit save so it sticks, and then your code should run. And I'm running it again to make sure, but it is working, right? So it makes me feel much, much better about the whole thing. So here's what I'd like to do now is I want to keep ramping up this example and adding to it. All right. The other thing I did want to show you is if you do remove the switch and save it and run it, just so you can see that it still works. Right. So this still allows it to take that file, read it into memory, store it, and then the read command does the work. The default, by the way, which is logical, is if you don't include the switch, read only is automatic. Why? Well, think about it. It makes sense. You don't want somebody changing a file accidentally. All right. So my preference would generally be that you know what you're doing with the file and you include the switch, but I'm just kind of throwing it out there. Now, one thing that you could also do, right? And so I'm just kind of giving you ideas here, is here we're taking the file read command and we're putting it in the print statement. Right. And we could do that. Or we could take that file.read and throw that in a variable and then just print X. That's a possibility. Let's show you that that works too. Some people will take it even further and we'll take this whole open command and put it inside the read. You can do it a number of different ways. You know, the bottom line is as long as you get it to work. Now there's another command that we're going to experiment with a little bit. I'm going to go back over to W3 schools here for just a second and see if I can find this one command, which is tell. And we're just going to experiment with this one a little bit, right? So like, what does this one do? It basically lets you know where the current position is in the file stream, right? And you can change that with the seek method. So for example, if I run this, why does it come back with 0? Well, because it's read the file and it's done, right? So if you want, we could add this statement, and I'm going to drop it into our code here. And it'll tell me where in the file we are after doing the commands that we did. And it says 89. So why does it say 89? Well, I'm going to speculate there's 89 characters here. So when it's all done, where is the cursor sitting is really what it's telling you. So I'm not sure how particularly useful that is, but there it is. You know, it depends on what you're trying to do. All right, there's another kind of an interesting little command that's related to that one called seek, and that was the one that they were kind of pointing out. So the seek method will reposition the cursor back to 0. So this one ties back to the example we were just looking at. So if I run this code, right? Oh yeah, but if I'm going to do that, I have to read the file here. So we're going to print it back out again. So I want you to watch these commands here. So first we're telling us where we're at, then we're going to seek it back to position 0 and then read the file again. So just so you can see. Right, so if we're going to read through the file again, instead of sitting at position 89, now it's sitting at the end and we'll read the whole file. Right. Useful depending on what you're doing, right? So if you need to like not only read through a file, but traverse it and move around, like moving your cursor through a file, you can do that stuff. I think it's kind of an interesting thought. All right. Another real common thing when you're working with files, because you know, if we look at the anatomy of a text file, so if I go here, open up my hello world file, and I see, you know, the text that I have in here, there's a lot of things that are repetitive, right? So why do files work well with loops? Well, let's take a look at it from the standpoint that this file's got 4 lines in it. You know, there's 4 lines. So there's a line, and then there's another line, then there's another line. And that's a repetition right there. If I look at one individual line, I can go, well, hey, here's a character, here's another character, here's another character, here's another character. That's also a repetition. Because there's repeating structures, whether they're characters or lines of text, I can traverse them using a loop structure. And that's really kind of what this next little tidbit is about. And so I'm going to just set up a counter variable here called I. I'm going to preset it to 1. And then I'm going to say for each line in the file, I'm going to read that line into this variable. I'm going to run this function that we haven't learned about yet called rstrip. And this is what really powerful one. What it does is it removes, well here, let's, returns a copy of the string with trailing white space removed. So if somebody's like type a word space, it removes that extra space at the end. So we're going to strip it. And in this case, we can also have it look for a particular thing like a line break, right? And then we'll print with an F string, of course. That's the most common approach. Line I, so it'll number our lines for us. We'll put in a colon, and then we'll take the line that was just read in and put it back on there. So we're reading in the lines. We're gonna drop in a number. So we're gonna say line 1, colon, then we're gonna put the text back up on the screen and then do another line. So we're gonna read through the file, break it apart, but we're adding line numbers to it. And then every time we go through, we're going to add a number. Now I have 4 lines of text. So it's going to take the text that I have and it's going to put line, number, colon, space in front of whatever I have. Save that. Let's run it and then watch the output. Which failed miserably, right? What is our syntax problem here? I'm looking at my syntax, and I don't know if it's because let's blot out this one and this one. Oops. Now let's try doing that loop. I'm going to run it one more time. Yeah, it's not quite doing it, is it? All right. This. Firing on all cylinders here tonight, folks. So I did get it to work, but what I ended up doing here is I ended up commenting out all the code in between. So for those of you trying to code along at home. So this is, all the code. So we're just opening the file and then we're traversing. And I think the file seek might have been messing us up a little bit, but whatever. If you do run this code, it will do what it's supposed to do, which is read the text in and append to it these things, right? So this code at the beginning, that's in this loop here. All right. I'm going to leave this stuff up on the screen, but I am going to pause for a break, and we will be back in 5 minutes, folks. All right, now that we're back, we're going to work on lab number 2. And we're going to kind of expand this a little bit. There's a couple of files here that are you're being asked to download, and these are actually script files or dialogue files from these movies that you see here. So just trying to have a little fun with it, basically. So what I do recommend is that you download each of them. And then take them from your downloads folder. Go to the folder where they're located. Maybe make a copy of them would be wise rather than doing a cut. And then we're going to put that in a subfolder called Lab 2 files. So I'm going to go to the folder that we're working on. And then another new folder here, Lab 2 files. Notice no spaces, uppercase L, uppercase F. And then I'm going to place those here. Now, if you want to take a look inside, it's okay. You can see what the content is here. And you can see it's dialogue. And then basically the format of the dialogue is whoever's speaking it followed by what they're speaking, right? So there is a format to it. And for example, if you're looking at Barry here and what he's doing or saying, I should say, that's different than this description file, right? Where it starts with a parenthesis, it's not quite the same thing, right? So that can be useful for us when we're processing the information in this file. All right, so that's what that one looks like. You want to look at Shrek. There you go. If you want to memorize all the dialogue, here's your mechanism, folks. Right, if you need help with it. All right. Back one folder up is where we're going to create our Python file. So let's go back over to Visual Studio Code here. And I'm on the same level as the first lab file. And then I'm going to create a new file. And this is going to be module 6 lab 2 dot py. All right. All right, so let's take a look at the directions on what we need to do here aside from just deal with those two files. So we've completed the first bullet and it says open the file and create a script to get every line from Barry. Okay, so that's going to be our little objective. All right, so let's get that and then make that just that piece happen. All right. And then we'll do the next steps. So that's our current directive. And so how would we accomplish that? Well, why don't, since we're grabbing the script, let's create a variable called script. And then let's call in an open command. So we say open. And then inside the parentheses, I want you to notice how I'm going to do this. This is kind of, you know what, let's take this one step at a time. I don't want to like kind of blow all of it right away. We're going to open this in read mode and we need it to be in a certain spot. Now, did we just put it one folder deep, right? Right, we put it one folder deep. So let's just call it to start with. So let's double quotes. We'll say lab 2 files / and we want to bring in is it from the Shrek movie? I'm forgetting what I'm doing.
Or the B movie. There's 2. We saved 2. B movie.txt and Shrek.txt.
We prefer to do this in read-only mode, so we're going to designate the R switch. And here's what I would do just to start is let's just take a look at it. My dog coming back and forth here. I don't know if you guys can hear her or not. Oh,
She'll be glad when class is over.
Script. I think she's looking for me to take her for a walk. All right. Either that or she just came back from one. So we were able to read it in. Notice this is, actually not a huge file, but pretty large file, right? Lots of lines in there. So it's successfully reading it into memory and we're successfully outputting it. And that's not a bad thing to do. That's just a little test. Okay. Does that fulfill it? Open and create a script to read every line from Barry. All right, so doesn't that sound like a repetitive process? Yeah, totally. I think a loop is the right tool here to do that. So not that this isn't pertinent, but this is just a little test. So let's just comment that out. And now let's focus on the loop. However, as I'm reading through the lines, I'm going to create myself a Boolean variable to mark every time I find a character name or line that is not what I'm looking for. And that will trigger me looking again. And then if it is the thing I'm looking for, then I can do the output of what they say. Right. So just to kind of focus it down. So I'm going to create one called is character. I'm going to preset it to false with capital F. And then if you want a little context on it, this is the note that I have on it. And I should talk about the word flag, right? So whenever we use Booleans, we say true, false, it's like a flag, flags up and flags down, one state or another. So that's the flag we're just presetting to kind of track for Barry. Now I'm going to say for each line in the script, you see if you name stuff well too, it kind of makes sense. We're going to process the text. We're going to do the R strip thing. So we're going to say line, and then we're just going to run it through R strip. Remove everything except for line matrix. So now we're going to do a statement here, and we're going to say if is character. Now I don't have to say true or false here because that's implied, right? So it's either true or false, and that's what triggers an if statement. We're going to print the line that's stored. Okay, so this is kind of weird. So the first time through, it's not going to do it. Right? That's the logic. It's just not going to do it. All right. There's no else on this. We're just not going to do it. All right. Then we can say if the line is equivalent to whatever character name we come up with. And so we need a variable here for that. I'm just going to call it character name. So that way we can feed in any character we want. So in this case, I could just hard code Barry, for example. And then we'll follow it with a colon. And now why do I do that? Because like if you look at how those files were put together, right? When a character is speaking, it's followed by a colon. So whatever character plus a colon, in this situation, that doesn't happen. You see the logic, right? So sometimes like for something like this, you just have to kind of think about it a little bit to get it to work correctly. Right? And then you need a colon here to start the if statement. So what happens if the character name will match? Now we're going to need to somewhere declare this character name, right? Well, what would we do in that situation? We're going to flip that switch to true. Otherwise, we'll leave it false. All right, so we're just trying to accommodate each situation. All right. So let's think about what this would then accomplish in terms of running. If we're looping, when does the loop stop? Okay, this is kind of another thing we haven't talked about. It's automatic. It reads through the file like it does a list or anything else, and it will output it sequentially just because of that's what it does with the file, right? So how many times? As long as the file is, if it's 4 lines, if it's 1,000 lines, if it's 10,000 lines, it will just keep running each time executing it. It strips the line that it reads in. If the character matches, it prints it. If it doesn't, it does not. It's really like that simple. So now the question is, where do we get the character name from? All right, well, now I'm thinking, now I got to feed that in. Where am I going to feed that in from? Well, what about if I ask the user for that piece of information? But you know what would be really kind of helpful is why don't we create a function that runs all, because that way they can ask multiple times. And we can set all that up in loops if we wish. So let's begin by thinking that all these actions that we're taking, so everything here is going to be part of some bigger function. And I apologize for bouncing around so much. And so I'm actually going to highlight them all. I'm going to tab them in one tab stop, and then I'm going to create a function. And I'm going to call it print lines by. What are we going to send into it? Well, what if we prompt for the file name? Hey, you know what? Because I have 2 files, I could prompt for the file name and prompt for a character name from that file. So I'm going to feed in those two pieces of information, file name and character name. Like so. So that's the whole function then. This part's not needed. Get up your code. Now we need to call it. So let's figure out how we're going to call this. We can keep it really simple. Call the function. Inside here, we can do, we can hard code which movie it is. So for example, I could hard code the movie. And now think about this. This will trigger the naming of the file, and I would have to append a .txt to it. So I got to handle that piece too. So I just put that in my head so I don't forget to do it. And then for the other part, I'll have them input the character name and something really simple. Let's see, what can we say? What character the B the that's a question, I guess. Somewhere here, I'm breaking my code. Oh, right there. Right, you guys see that? I was missing that. All right, we can do the same thing. For the Shrek movie, but maybe we should just try this and see if we can get this to work. I mean, this is kind of the directive, but now I'm sending in like which file I'm contending with, right? And rather than hard code this in here, I could switch that to the F-string format and just call it file name, like what's being passed in. So I can pass that information in. This has to switch to an F-string thing, though. So just revise syntax here and here. Right. I think we have enough here right now to give this a try. Make sure your syntax matches though, right? So here comes the save. Hitting the run button, folks. Let's try Barry. And I think what's kind of fascinating about this is you look at how quickly it did that. I mean, almost instantaneously. Then the question becomes, did it do so accurately? And the only way to really verify that, and I would implore you to at least once look through. So Barry's first line is yellow, black, yellow, blah, blah, blah. Is that correct? Yes, right? Then followed by coming, hang on a second, right? Hello, et cetera, et cetera. So it did match up pretty slick. So it's finding that line, reading the character name from the line and finding that snippet and then returning the following line. Brilliant. You know, it's such a simple amount of code to be able to do something so powerful.
Can I ask you a question?
Yes.
How did you get rid of the red question mark on B movie? Because I have a red question mark and then I lost you. Right there. Print lines. B movie. I can't figure out why I have a red.
All right, folks, that completes lab 2, and we're going to move on to lab 3. So this video ends here.